Assalamualaikum. Today we discuss about the matrices. Matrices was introduced by J.J. Stowe in 1814 to 1897. He was a British mathematician. After that, Arthur Cayley came and developed the theory of matrices and used it in algebraic of matrices. Now, if we talk about the raw matrix, the matrix which is basically matrix is enclosed in square brackets, these type of brackets. If we talk about raw matrix, raw means this and column means this. Raw means horizontal or vertical and column means horizontal. Raw means vertical, column means horizontal. Raw means vertical, column means horizontal. Okay, now if we talk about the raw matrices, it means A, B, C. These are the elements. A, B, C are the elements, and the formation of this is vertical, in the form of vertical. This means it is a raw. If it would be in the horizontal, then it's mean that is a column matrix. We take the example of this two. Then C, A, B, C. This is in the form of horizontal, means it is a column matrices. Okay, if we talk about a square matrix, means whose row and column both are equal, like A, B, C, D, B. Again, how many rows are there? 1, 2. 2 rows are there. A, B is a row and C, B is a row. There are 2 rows. If we talk about the columns, how many columns are there? 2. A, C, B, B. Means whose row and column are equal is called the square matrix. We discuss here in the 9 element A, B, C, B, C, A, D, C, Q. How many rows are there? 3. 1, 2, 3. And how many columns? 1, 2, 3. 3 rows, 3 columns means it's a square matrix. Okay. If we talk about rectangular matrix, means whose rows are not equal to the column. A, B, C, C, B, D. How many rows are there? 1, 2. 2 rows and how many columns? 1, 2, 3. Means it's not a square matrix but it is a rectangular matrix. If we talk about null matrix means whose all elements are 0, 1, 0, 0, 0, 0, 0. This is null matrix. If we take example in the square matrix, so 0, 0, 0, 0. It is a. If we talk about the diagonal matrix, diagonal matrix means whose diagonal element are something, means A, 0, 0, 0, B, 0, 0, 0, C, whose diagonal elements are here. Means even the single element is diagonal, which means it's a diagonal matrix. Like for example, here the 3 diagonal elements A, B and C. This is the line of diagonal. Always remember that this is a line of diagonal. If we take the example that whose diagonal element is only one diagonal element, 0, 0, 0, 0, 0, 0, 0, 0. It is also called the diagonal matrices because whose element is even one in the form of diagonal. This is the line of diagonal. I discussed you that this is the line of diagonal, and even a single element is present in the line of diagonal, which means it is a diagonal matrices. Okay, whose other element are except diagonal element, whose other elements are 0, always 0. Okay, like if take example of that A, 0 0. These elements must be 0 0 or C 0 0 0 0. Except diagonal element means non-diagonal elements must be 0. Okay, and now we'll discuss about scalar matrix. What is a scalar matrix? A scalar matrix is a type of diagonal matrix in which the diagonal elements are same. For example, if we take example that A 0 0 0 A 0 0 0 A means whose diagonal elements are same. See the line of diagonal. It's a line of diagonal. Here is written A, here is written A, here is written A. Means the diagonal elements all are same. It is a scalar matrices. I am writing a matrices. Guess which matrices is that? Okay. C 0 0 0 C 0 0 0 A. Guess which matrices is that? It is simply diagonal matrix because its all diagonal elements are not same. It is a same, but here is remaining A, which is not same to these two elements, which means it's a diagonal matrix, not a scalar matrix. Now we discuss about unit or identity matrix. Well, what's the difference between unit or identity? Means same. Unit and identity are also the type of diagonal matrix in which the diagonal elements are 1. It is a type of diagonal matrices in which the diagonal element are always 1. This is the unit matrix. It is also a scalar matrix because all the elements are same. See, all the diagonal elements are same 1 1 1. But it is most probably it is unit matrices because it has 1 1 1. It is a rule of unit matrix. When the diagonal element are 1, it is called the unit matrices or identity matrices. If we talk about triangular matrix, which means whose upper or lower element, basically there are two type of triangular matrix, upper triangular matrix and lower triangular matrix. We will discuss about the upper triangular matrix whose element after diagonal are always non-zero. Means diagonal element, make first diagonal 1 2 3 5 6 0 0 0. Here's C. Here's our triangle is made. Here triangle is made, which means these are the diagonal elements, and the upper diagonal, the element which are upper than the diagonal elements must be non-zero, and the element which are lower than the diagonal element must be 0. It's a type of upper triangular matrices. If we discuss about the lower triangular matrices, 1 2 1 6 1 2 9 0 0 0. It's mean that who made the lower triangle is the diagonal element, and the below the element which are below the diagonal element must be non-zero. These are non-zero, 1 2 9. These are the non-zero, and upper element must be 0. It is called the lower triangular matrices. If we talk about triangular matrix whose diagonal element are 0 and remaining are 1. Oh, whose diagonal element are 0, 0, 0, 1, 1, 1, 1, 1, 1. This is called a triangular matrix. It may be upper or lower. Okay. If we talk about the transpose of a matrices, I'm making a matrices A, B, C, 1, 2, 3, 1, 1, 6. This is a matrix. If we talk about transpose, means you have to interchange the row into column, second row to second column, and third row to third column. Like this is the matrix ABC 1, 2, 3, 1, 1, 6. Change row into column. First row is ABC. Make it column A, B, C. Second row is 1, 2, 3. Make the column 1, 2, 3. Third row is 1, 1, 6. Make the column 1, 1, 6. This is called the transpose of a matrix. Okay. Now, if we discuss about, we have done with the transpose. Now we do the symmetry matrix. Symmetry matrix is A transpose is equals to A. Means if we take the transpose of A, it becomes the, if we talk about if we take the transpose of A, it becomes again A. Like take the example of it. If a matrix is A is equals to, for example, 1, 3, 3, 2. This is the row, this is the row, this is the column, this is the column. Change it, interchange them. Row into column 1, 3, row into column 3, 2. It becomes as same as the A. It means A transpose is equals to A. Now maybe it's clear. If we talk about idempotent matrices, if we talk about idempotent matrices, it means A square is equals to A. A square is equals to A. Okay. Now, if we talk about nilpotent, means A power is equals to 0. If we take power of A, it becomes 0. Like power 2 becomes 0. If it becomes 0, it is nilpotent one. If we take the power of A, and the answer becomes, if we take the power of A, and the answer becomes 0, it means it's a nilpotent vector. Oh, matrices. If we talk about involuntary matrices means if we take the square of matrices, it becomes the identity matrices. We have discussed the identity matrix previously here, where that unit or identity we have done with that. As I discussed that the unit matrices or identity matrices is where the diagonal elements are 1 and the non-diagonals are 0. That's the unit matrix. If we take the square of a matrix and it becomes the identity matrix, it is an involuntary matrices. If we talk about periodic matrix is A k plus 1 is equals to A. AK plus 1 is equals to K. K is greater than or equal to 1. K should be greater than or equals to 1. If we take example, for example, 2. 2 plus 1, 3. If we take the power 3, it becomes 8. last Hermitian is remaining. Okay, Hermitian. Hermitian matrices is a matrices in which we take the conjugate of it and transpose of it. It becomes again the A conjugate and transpose is equals to this the T. Transpose is equals to A. This is called the Hermitian matrix. If we talk about skew Hermitian, the answer will be in the form of minus. This is called a skew Hermitian.